double integral of square root of a square minus x square minus y square dx dy over semicircle x square plus y square equal to ax in the positive quadrant. Now semicircle is given to us, so we need to change these Cartesian coordinates into the polar coordinates. So changing to the polar coordinates, we know that x is r cos theta and y is r sin theta. To calculate x square plus y square, we get x square as r square cos square theta plus y square is r square sin square theta. So taking r square common, we know that this is 1. Cos square theta plus sin square theta is 1. So this is equal to r square. Now given to us the semicircle x square plus y square equal to ax, we need to draw this semicircle first. So first let's have the equation of the circle. Let's get that equation. So for that, just take ax to the other side plus y square equal to 0. To make the perfect square, can I write ax as twice x a by 2 plus y square equal to 0, and to make the perfect square, I am adding a square by 4 and subtracting a square by 4. Plus y square equal to 0. From here you get x minus a by 2 whole square plus y square equal to a by 2 whole square. This is your center, this is your radius, right? So the center is a by 2 and y square means y minus 0 whole square, right? So the center is a by 2 comma 0. So if this is your a, so at the center I am having a by 2 comma 0. This is your center from this equation of circle. You can also write y square as y minus 0 whole square. This is your h, this is your k. So from there you get the center as a by 2, 0. So making the semicircle, so I'm just drawing the semicircle. Right? And now making the wedge. This is your origin. If I suppose to make the wedge, which describes that r is varying from 0 to, what is the equation for the semicircle? It is x square plus y square equal to ax. X square plus y square equal to ax. I know that x square plus y square is r square from here, and this is equal to ax, which means r square is equal to, writing the value for x, that is r cos theta. So from here you get r is equal to a cos theta. So at this point r is varying from 0 to a cos theta, right? And theta is because it is a semicircle lying in the first quadrant only, so theta is varying from 0 to pi by 2, right? So we get the limits for r as 0 to a cos theta, and for theta we have 0 to pi by 2. So the limits for r is from 0 to a cos theta, and limits for theta is from 0 to pi by 2. So this is our given integral, double integral. Changing it to the polar coordinates, what I get is just writing the limits for r as from 0 to a cos theta, and for theta from 0 to pi by 2. Please remember, always constants limits comes on the outside the last integral, and this is a square minus r square, because x square plus y square is r square, and the formula is r dr d theta, right? Now to calculate the innermost integral, let me separately solve this integral. Square root of a square minus r square r dr. So this is equal to solve this integral, I'm putting a square minus r square is equal to t. So I get minus 2r dr is equal to dt. I need negative 2r dr in the numerator, so I'm just multiplying and divide by negative 2. This is minus 1 by 2, and this will become square root of t into minus 2r dr is dt. So this is equal to minus 1 by 2. The integration for t power 1 by 2 is 3 by 2, t power 3 by 2 over 3 by 2. So this is equal to minus 1 by 2, 2 by 3, t power 3 by 2. 2 and 2 will be cancelled out. So you get minus 1 over 3 t power 3 by 2 plus c. Minus 1 over 3. Instead of t, just write a square minus r square power 3 by 2, and the limits are from 0 to a cos theta, and then d theta, right? So this is equal to 0 to pi by 2, taking minus 1 by 3 outside. When you put a cos theta over here, you get a square minus a square cos square theta. That will give you a square into 1 minus cos square theta. That is a square sine square theta. So you get a square sine square theta power 3 by 2. And when you put 0 over here, you get a square power 3 by 2 minus a square power 3 by 2 d theta. So this is minus 1 over 3, 0 to pi by 2. Solving this, we get a cube and sine cube theta minus this is a cube d theta. Because a cube is constant, taking this outside, minus a cube over 3, 0 to pi by 2. This is sine cube theta minus 1. Because I want to use the reduction formula, I'm separating this sine cube theta d theta minus integral 0 to pi by 2 d theta minus a cube over 3. Now to use the reduction formula, we know that the power is 3. This is the odd power. So in the numerator, we always subtract the power with odd numbers. So this is 3 minus 1, and 3 minus 3 is not required. Over, just write the power first and then subtract the power with the even numbers till you get 1. So 3 minus 2, and 3 minus 4 is not required because then you will get the negative answer. So stop here only. Minus, this is your theta, that is the limits from 0 to pi by 2. So this is equal to negative a cube over 3, and this is 3 minus 1, that is 2 over 3. 3 minus 2 is 1, minus this is pi by 2 simply, and then this is equal to a cube over 3. Just take the negative sign inside, you get pi by 2 minus 2 by 3. This is your required answer. Thank you.